Okay, so in this section we're going to talk about limit of a function and limit laws. Let's see this graph of a function f of x, which is x squared minus 1 over x minus 1. As you can see here on the denominator, when you put x equal to 1, this denominator would be 0. So we will have to make sure that this denominator is not 0 to define the function. So that means you cannot have x equal to 1 to make this function defined. So that's the reason, as if you look at the graph, you can see that there is no value when x is equal to 1. So that means the function is undefined when x equal to 1. Okay, so here our goal is to find out what happens when x approaches to 1. What happens when x is very close to 1. Okay, what happens to the value of the function when x is very close to 1. So this symbol means approach. X could approach. X means the value of x, the value of here. So we're talking about when the value on the x coordinate approach to 1. So there are two different directions: approach to 1 from left side, approach to 1 from the right side. And we are interested to find out what happens when x approaches to 1 from left or right side. And look at here, I'm going to use this table. When I plug x equal to value very close to 1, I know the function is undefined at 1, so I cannot pick x equal to 1, but I can pick something very close to 1. As you can see here, when x is 0.9, the value of the function is 1.9. You can just plug the value x equal to 0.9 here and calculate that. By looking this table, you can conclude that when x approaches to 1 either from left side or right side, the function approaches to 2. Okay, when x approaches to 1 either from left side or right side, the value of the function is going towards 2. So this idea now can be called as a limit of function. So what is the limit of function here? Limit of function means, this is the notation we're going to use. Limit, LIM, means it stands for limit of the function f of x when x approaches to 1. When x goes to 1 either from left side or right side, the value of the function goes to 2. This is called limit of function. Okay, so what is the limit of function? Sometime we have a function and which is not defined at some specific point, still we can approximate the value of that function close to that point. That approximation is called limit of function. So in this table, as you can see, when x approaches to 1 from left side and right side, both sides, the value of the function is going towards 2, and this is how we write it down, and this is called limit of function f of x when x approaches to 1. Okay, this concept is called limit of function. But make sure that when x approaches to 1 from either left side or right side, the value of the function should go towards the same value. Like in this table, either you take the left value or right value, then 1, then you see that the value is very close to 2. That's why that is called limit of function. Okay, so that's the simple one example of limit of function. Limit of function is a approximation of value of the function when x approaches to some specific value, where most of the time the value of the function is undefined, or we don't know what is the value of the function. Okay, so let's look at three different graphs here. The first graph, the very same one we were using in previous example. The second one, there is one additional point. This is a piecewise function. When x is not equal to 1, our function is similar to f of x, and when x equal to 1, the value of the function, this function, is 1. Here the function is x plus 1, which is very similar to the first function, which is just a simplification of the first function. Okay, and now we try to find out what happens when x approaches to 1. From previous example, we can say that the first graph, when x approaches to 1, the value of the function approaches to 2. So you can see here, when x is approaching to 1 from left side or right side, the value of the function is approaching to 2. That's 2, and that is the limit of the function. Okay, when x approaches to 1, the value of the function is approaching to 2, either from left side or right side. That is called limit of function. Look at the second example. When x approaches to 1 from left side or right side, one more time, the value of the function is approaching to 2, though the value of the function itself is 1, but here we write the same thing. When x approaches to 1, the value of the function, which is g of x, is approaching to 2. So again, the limit of this function is called 2. The limit of the function for this function is 2. Okay, though the value of the function at 1 is 1, the limit is 2. So the limit of the function for the second graph is 2. Third one, when x approaches to 1 from left side or right side, the value of the function is approaching to 2, and then value itself is also 2. So when x approaches to 1 from left side or right side, the value of the function is approaching to 2, and actually the value of the function at 1 is also 2. So this is the only situation where the value of the function and the limit of function are equal. So in all these three graphs, the limit of the function when x approaches to 1 is 2. For the first two graph, for the first one, the value of the function at 1 is undefined. For the second one, the value of the function at 1 is 1, which is different than the limit of the function. And third one, the value of the function and the limit of the function when x approaches to 1 is exact same. So you might have three different situations where limit value might be different than the the value of the function at that point. Okay, sometime you might have situation where the limit is not possible. Look at the first graph here. When x approaches to 0 from left side, you can see that this is the graph. The value is approaching to 0, but from the right side, the value is approaching to 1. So in this case, because they are approaching to two different value, we say the limit of function is not possible. Okay, when x approaches to 0, the value of the function is approaching to two different value from the left and right side, so the limit is not possible. So the limit when x approaches to 0 for this particular graph is not possible. Same thing is true for the second one. Look at here, when x approaches to 0 from the right side, the value is going up, and from the left side the value is going down, so they are going to be two different value. So whenever it's approaching towards two different value, the limit is not possible. In this example, when x approaches to 0 from the left side, the value is going to be 0, but from the right side it is fluctuating between -1 and +1. So they are not giving you the unique value from the both direction. That's the reason none of this function has a limit as x approaches to 0. So to have the limit of a function at some point, the limit from the left side and limit from the right side should be equal. Let's look at one example here. You have given a graph of a function g of x, and we need to find out this information. This is the graph. What is the limit of the function g of x when x approaches to 1? So look at here, the 1 value on the x coordinate system here. This is 1. So what happens when x is approaching to 1 from the left side? From the left side, we need to use this graph. The graph is going towards 1. But from the right side, you need to use this graph. So the graph is going towards 0. So that means from left side, the graph is approaching towards 1, and then from the right side to the 1, the graph is approaching towards 0. So that means limit does not exist. Does not exist. So you might say DNE or does not exist. Okay, let's check the second one. What happens when x approaches to 2? 2 is here. So we have to do the same thing. What happens when approaching from the left side and then right side? And if you focus on this graph here, if you are using the left side graph, this graph is approaching to 1, and from the right side graph, the graph is approaching to 1. So that means the limit of this function when x approaches to 2 is 1. So look at for the 3, this graph is approaching towards 0 from the left side and from the right side, so it's a 0. For the 4, for this one, which is 2.5, as you can see that 2.5 is somewhere here, 2 and 2.5, so you can see that it's 0.5. When x approaches to 1 from 2.5 from the left side or the right side, the graph is approaching to the same value, which is approximately 0.5. Okay, so we can use a graph for finding the limit of a function. There are some laws we need to we need to know, we need to understand. So limit laws, and if L, M, C, and K are real numbers, and there is a L means it's a limit of the function f of x. When x approaches to C, capital M means this is the limit of function g of x when x approaches to C. Then these are the rules we can apply. Sum rule: limit of sum of the function is actually the sum of the limit. Difference rule: limit of difference of the function is actually the difference of the limit. Constant multiple rule: so you can see that there is a constant time function, so you can bring this constant outside and you can find the limit, which is actually L. Product rule: limit of product of function is actually product of the limit. Quotient rule: you can do the same thing. This is the limit for the f of x, this is limit for the g of x, and that's true if the limit on the denominator is not 0. You can only apply this quotient rule if the denominator is not 0. Power rule: even there is a power, we don't care, we can just find the limit of the function inside here, and we can just take the power of that limit. Root rule: that means if there is a nth root, then we can find the limit inside and we can just take the nth root of that limit. If n is even, we assume that the function is positive for this one, for this root rule, because if n is even, inside the radical sign there should be positive value. So they are limit laws. If you are dealing with a polynomial, this is a polynomial, p of x is a polynomial, and if you want to find out the limit of the polynomial, it's actually finding the value of the polynomial at that point. Another rule that's called quotient rule: if you have polynomial on the top, polynomial on the bottom, and if you are interested to find the limit, that is actually the value of the polynomial on the top and the value of the polynomial on the bottom, but make sure that the denominator part is not 0. Let's look at one example here. Find the limit of this polynomial negative x squared plus 9x minus 8 when x approaches to 7. If you go back here and check this rule, it says finding the limit of the polynomial is very easy. Just find the value of the polynomial at that point. So we're going to do the same thing here. Just plug x equal to negative 7. Sorry, x equal to positive 7. 9 times 7, and there is an 8, which is 49, 63 minus 8. So 49 and 8 is negative 57 plus 63, which is 6, positive 6. So limit of this polynomial when x approaches to 7 is positive 6. There is one other example. There is a polynomial on the top, there is a polynomial on the bottom. If you try to plug x equal to 17 on the top and bottom, on the bottom part you are going to get x squared minus 289. If you replace this x by 17, then it would be 0 actually. So we cannot use the limit laws here directly. So before applying the limit, we have to do some simplification. So in this problem, what we can do is we can find out the factors on the denominator. So if you remember this this expression, this formula, a square minus b square can be written as a plus b times a minus b. In our case, x square minus 17 square, 17 square means 289, so I can write it down as x minus 17 times x plus 17. So on the bottom I can write x plus 17 and x minus 17. So what we can do is, before plugging this limit, we can just cancel out the common denominator, common factors. So now we can apply that quotient rule. Now we can replace this x by 17 because that's not going to give us 0 on the denominator. So that will be 1 over 34. 17 plus 17 is 34. Okay, this is the expression we use in section 2.1 for finding the slope of the tangent line, and this is quite useful expression. So limit of the form, this you can see this expression quite frequently. So let's find out this expression for this particular function when x is negative 8. When x is negative 8. So there are two different ways you can evaluate this value. You can first find this value and finally put x equal to negative 8, or you can just put x equal to negative 8 at the beginning. So I'm going to just find this value in general, and finally I'm going to put x equal to negative 8 for finding this expression. So as you can see that there is a f(x plus h) and there is a f of x. F of x, no problem. Let's find out f(x plus h), meaning just replace x by x plus h on the right side. So this means it's x plus h times x plus h, x plus h times x plus h, which is basically x squared plus 2xh plus h squared. Now we're going to plug this value on the top of this expression here. So limit h approach to 0, f x plus h is x squared plus 2 times x times h plus h squared minus f of x is x squared over h. I can just cancel out this positive x squared and negative x squared, and now I can factor out h on the top, and now I can find the limit of this expression. When h approaches to 0, there is no h on the first part, but there is a h here, so that will give us just 2x. So this part goes to 0. But we are interested to find this expression when x is negative 8. So the value would be 2 times negative 8, which is negative 16. Okay, so basically this is the slope of the tangent line when x is negative 8. Okay, sometime we might have this kind of situation. Look at this graph of function h, g and f. As you can see that the graph f is in between graph of h and graph of g. The graph of f is sandwiched between the graph of g and h. If you have this kind of situation, as you can see that when x approaches to c from left side and from right side, for the function h and function g, the value is approaching to L. So now we can use this graph to visualize the situation, and we can talk about this theorem that's called sandwich theorem. In this theorem, suppose that you have a function f of x which is in between g of x and h of x, and suppose we know that the limit of the function, the left function g of x and then right function h of x, when x approaches to c is L, then according to this sandwich theorem, which we don't have to prove it here, but we can use this theorem as a tool, the limit of this in between function should be also the same. Okay, so if the limit on the left side and the limit on the right side, when x is approaching to the same value, it's same common, then the limit of the middle function should be the same value. We can use this thing here for this example. F of x is in between these two values, these two functions, which is square root of 10 minus 7 x squared from the left and square root of 10 minus x squared from the right. We are interested to find what is the limit of the function when x approaches to 0. So to use this sandwich theorem, we are going to find out the limit of this function when x approaches to 0. Limit of this function when x approaches to 0. So this is by using limit laws, we can just say this is 10 minus 7 times 0, which is square root of 10. 7 times 0 is 0. And limit of this right function when x approaches to 0, the limit of 10 minus x squared is 10 minus 0, which is square root of 10. So because the left hand limit and right hand limit, both of them are same, by using the sandwich theorem, we can say that the limit of middle function when x approaches to 0 is also the same value by using the sandwich theorem. Okay, and that's section 2.2.